Hola. So know you said to do like three from each page, but these questions are actually pretty easy and it's gonna go really quick. Kind of the hard part is about like what is the question actually asking. And then the math part is easy. So for this one, find the net change in the value of the function between given inputs. So the first thing, Zoom tools are all different. So I'm trying to figure this out. So the value of the function, when they say that, they mean like the y. Like, so find the net change. Net change just means like overall, like if something ends at like 100 and begins at 50, then it changes 50. Um, so you're going to find the y values at each end. So like this and this. So the easiest way to organize this kind of thing, because you could do like a lot of these mentally, is just to make like a set of 2 points. So 1 to 5, those are your x values. And we're going to find the y values. So I'll just show the sample calculation here, what I'm doing. So I'm going to do 3 times 1 minus 2, so that's 1. Goes here. And then I'm going to plug in the 5s. 3 times 5, 15, minus 2 is 13. So the net change, you just do, it's basically asking y2 minus y1. So I'll put that in the box here. That's what it's asking. So you see those words, just automatically do that. So in this case, I'll put the answers different color. So I have 13 minus 1, that's 12. Right, next one, from 3 to 5. So again, I'm going to set up just these to keep things organized. So the 3 and the 5 are the x values. And I'm going to find the y values. So I'll show it the calculation with one of those things. So 4 minus 15, we're going to negative 11. And I'm going to plug in a 5. So 4 minus 25, that's negative 21. Now it says net change, those come with signs as well. So it was 12 before because we did 13 minus 11 minus 1 to get 12. Here we'll do this minus this, which is going to be negative value. Or you can count too. You can see, okay, this goes down 10. It says minus 10. Next guy, negative 2 to 5. I'm going to set up these here. You got the squared there, so just be careful with that. So I'm going to do 1 minus, and then parentheses, negative 2. We'll use parentheses, plugging stuff in. That's 1 minus 4, so negative 3. And then it's going to be 1 minus 25, negative 24. Nice, so you could subtract those, like do this y2 minus y1. I'm just going to do it mentally. It went down 21, so it's going to be negative 21. And this last guy here, so negative 3 to 6. You could like, pause this and try these on your own, so see if you're getting the same things. So negative 3 squared is 9 plus 5 is 14. So come out to 41. Let's see, just subtract those, and that'll be 27. Yeah, that's all there is to those. So I'll go on the next one. I haven't used this in a while. Still have that wish picture. Yeah, piecewise functions, they can get a little confusing to draw and whatnot. But to evaluate, it's kind of easy. You just got to figure out like which piece you're using. So this is f of negative 5. Negative 5 is less than 5. So I want to use the first one. So I want to plug in negative 5 into here like this. So 3 times negative 5 is negative 15 plus 1 is negative 14. F of 0, so 0 is also less than 5. So I'm going to do this guy here, 3 times 0 plus 1, and get 1. 1/3 is also less than 5. So we're still using this one. So I'm going to do 3 times 1/3 plus 1. So that's 1 plus 1, 2. Here's where I gotta be careful. F of 5. All right, so that actually follows the second one because this is greater than or equal to 5. So I'm gonna square 5 and subtract 1 and get 24. Likewise, the last one is going to use the second function. So I'm going to do 6 squared minus 1 and get 35. So it's just a matter of choosing, which one of these fits the x value described. Okay. F of -3. Okay, so that's this one where it's -3 is less than or equal to 2. That just says 5, so that's like a flat line. So there's no computation. You don't actually plug it in. The answer is just 5 for that one. So f of 3, -3 equals 5. F of 0, that is less than or equal to 2. Again, no computation. It's just 5 because nothing to plug in. Here's the one you got to watch out because this is 2 itself. So you want to pick this one still because it has the equal to sign. So that's going to be 5. These other two, 3 and 5, those are both bigger than 2, so you're going to use the second function. So this one is going to match up with this part. So 2 times 3 minus 3 is 3. And f of 5, again, is this part. So I'm going to do 2 times 5 right here, and minus 3 is 7. Okay, so it's a little messy, but all your answers are right here. Yes. At 35, I don't have any questions with that. It was cut off, but I can make up some. So let's say for 35, um, I want to know what f of 0 is. You would look at this as 3 parts. So less than or equal to -1, in between -1 and 1, and greater than 1. So this would fit right here, and you would plug in 0. But when you plug in 0, it's just that number. So f of 0 equals 0. Anything in between will be the same thing. So like if I did f of 1/2, it'll also be just 1/2 because it just says x for that one. If I did say like f of -1, that would actually be the first function, this part right here, because of the equal to sign. So you'd plug in, I'll just show the work here. So -1 squared plus 2 times -1. So that's 1 minus 2 is -1. If I was doing instead, say f of 1, that would fit with the middle part. So that is just b1. And let's say I did f of, say, 90. X value 90, you got to figure out which part that is described in. So it'll be the third one. So it looks like our answer is just -1. Right, so those are some sample calculations there. Let's move it on. Domain and range. Okay, so domain and range are about like possible x and y values you could have. I think you guys are doing like the notation with the parentheses and brackets. Let's type this out then. Basically, want to be familiar with the way the functions are. So like 53 is a linear function. Um, so linear functions like mx plus b is like all real numbers. So the way you would do that is parentheses, negative infinity to infinity. Of course, you draw the infinity sign there. And range as well is the same thing. So it's like a rule with like polynomials where the domain and range is, I was about to say the wrong thing. Domain is always all real numbers. Range is a little different. So we see that for 54. So domain, you want to ask yourself, what are possible numbers you could plug in for x? And here you could plug in anything. It doesn't matter. It works. You're able to figure out the answer. So we're going to say domain is all real numbers, negative infinity, positive infinity. However, you won't get the same thing for range. You want to think about like what the lowest value would be. So simply put, like for this is a parabola. You do a quadratic function. So you want to think about the shape, like what that looks like. So those are U-shaped like this. And it goes upside down or right side up, depending on what you have. So this is a right side up one because this is positive. So your lowest value, that's what we want to know when we come up with the range. And you do that by finding the vertex. So if you get a parabola quadratic function, you find the vertex. There are a number of ways you could do that. Like this one, I know it right away because it's like a relatively simple one. But normally you would do negative b over 2a, which is the axis of symmetry. Okay, so to find the vertex, you would do find the axis of symmetry first. And then plug this x value in to find the y value. So like I said, this is a like more simple one, so this could be done mentally, but like to show that the steps you would do is a negative b over 2a. There is no b. You know how like there ax squared plus bx plus c. There's no b, so that's 0. So negative b over 2a comes out to minus the 0 over 2 times 5, which is just 0. And you would plug 0 back into the function. So you do 5, 0 squared plus 4, and it's 4. You could also think about what this looks like. This is the easily graphable thing because the 4, when there's no b, it's centered around the y-axis. So this actually starts at 4 here and goes up, and it's like steep because there's like a 5 there. So it's a steep one like that. So to write the range has a minimum value of 4 and it just goes up and up. So you start with 4, but I'm going to include that. I'm going to put a bracket and it goes up to positive infinity like that. Infinities always have the parenthesis. All right, let me clear some space here. Yeah, all right, it's good enough. All right, so the next one's the absolute value function. Absolute value functions work like similar to parabolas in that they have some kind of maximum or minimum. Those are V-shaped. So let's jot down some of these details here. So we got there's 55. Absolute value function looks like a V. This one is right side up. So it has a minimum Y value. You're going to be finding the vertex here. I want to say this. Absolute value functions can be written like this. So you have like y equals a, and then absolute value of x minus h plus k, and h comma k is the vertex. So in this case, we don't have an h there. So the vertex would have a x coordinate of 0, and the k is 3. So to put this all together with domain and range, the domain is all real numbers because you could plug in anything you want for that. And it's going to be the same for all absolute value functions. The range will start at 3 and go up to infinity. You could understand any of these better just by producing a graph. So what the graph looks like here. X and Y. So it's going to start at 3. Right here, that's the vertex. The A value for this one's 1, which means that it's going to go up evenly like this, like kind of like a slope of 1, slope of -1 on the other side. All right, 55 is kind of annoying. Okay, so a lot going on with 55. See, you have a square root, so that affects the domain. It's not going to be all real numbers. You want to make use of the fact that what's inside this has to be positive or 0. So we start off by writing that as inequality to figure it out. I want to say x minus 1 has to be greater than or equal to 0, which tells me that x has to be greater than or equal to 1. Because if it wasn't, if you put in, say, like a 0 here or a negative number, you're going to wind up with a negative, and we can't take the square root of that. So right here, this is the domain. So let me express that like we did with the other ones. So it's going to be domain starts at 1 and goes to infinity. Oh, we're going to put brackets there, actually. So you could have a 1 inside. The range, there is like a actual way to find like the range like that you're supposed to do. But I'm gonna say for this one to think about maximum minute, like just kind of just think it out a little bit. So like the lowest value you could possibly plug in is a 1. You can't go lower than that. So if I were to actually plug in that 1 like this, I would just get 2. And 2 is the lowest Y value you can get. So I'm not really following any rules here. I'm just kind of reasoning it out. So that tells me that the range would have to start at 2 with a bracket because it's possible and go to infinity. And if you want to know what the graph of this looks like, it's a square root function, so it's like a parabola on its side. And we don't do like a whole lot of those, so you could do like an XY chart to figure out what's going on, and then graph it and like make sense from there. So like what I'm about to show you, I don't recommend doing with time. You might run out of time, but like if you're not sure, make like an XY chart to help you figure out like domain range, all that. So I have X here, Y here. All right, so if I try to put in something less than 1, it's not going to work. Not going to give me an answer. So I'm going to start with 1. We already did that. We get 2. Maybe I'll plug in 2. So 2 here, 2 minus 1. It works out to 3. I'm computing all this right now. There's something like 3. That's going to be too hard to compute. So I'm going to plug in 5. The reason why I'm doing that is so that I could do 5 minus 1 and get 4 inside here, which I could take the square root of. The whole thing winds up coming to 4. Next one that works nicely is 10. So 10 minus 1, 9. Square root of that is 3. And 2, we get 5. So we have enough to kind of like figure out what it looks like here at this point. So we got 1, 2. That's like the starting point. That's kind of like the vertex on its side. That's not really like what they call it, but this. I think I'm kind of like over explaining these, but whatever. 10. All right, so you kind of see like the shape here, like this. All right, so the x values start at 1 right here and go to infinity. Y values start at 2 and go to infinity, which is what we're expressing right here. All right, last guy. So this is f of x equals 3x. This is a linear function. So normally linear functions would have domain and range of this, all real numbers. Like in 53, that's the answer to this. And if you notice, this is like the same function as this one down here, but it's saying only for a certain span, and they're giving us x values. So there's like way too much on the screen right now. Okay. So the answer for domain is actually kind of given to us because they like restricted it. It's saying it's going from -2 to 6. We got those less than or equal to signs, so those are included. We put brackets. And then for the range, you just want to find out the y values at those points. So this is kind of like almost like the other page. Like make points here, -2 and 6. So if I plug in a -2 into this, I'm going to get a -6. If I plug in a 6, I'm going to get 18. And so the y values are going from -6 to 18. And that's the brackets. All right, and that's it.